Okay, breakout students, in this video today we're going to be learning how to solve something called radical equations. Okay, radical equations. And give me just 1 second. I forgot to plug in the receiver to my MemoPad, so give me just 1 second to plug that in. There we go. And let's see if it's working now. And it's still not. Let me pause this. I'll be back in a second. Okay, there we go. So anyways, guys, we're going to learn how to solve radical equations today. Now, your heading, I hope that you'll write this down and have really super organized notes and keep this notebook for years to come. I hope that you will do that. But anyways, the heading is solving radical equations. The lesson number is 7.5. We've spent 2 videos in lesson 7.5, okay? And this is the second part today. Be sure to include today's date in your notes. Always important to be able to look back and know what date during the year we covered something. Now, before we get into this new material, it would behoove us, that means benefit us greatly, to just quickly review what kind of equations we have learned to solve so far this year. Now, I'm going to go from memory, so I might forget a couple. Okay, when I typed this up, I just went from memory. I did not go back and look in the book. We've accomplished a lot this year. It's very encouraging, very exciting. Obviously, we start off with linear equations. Those are really easy. Then we solve quadratic equations. Remember, we learned 3 methods: square root method, complete the square method, and the quadratic formula method. We learned how to solve absolute value equations, something like this. And we learned how to first isolate the absolute value, and then from that write 2 different equations and get out 2 different answers. By the way, I did not expect you to write all this down. Okay, I'm just kind of rambling right now. Multivariable equations, something like 2ab squared minus c equals 2b, and you would solve that equation for a or b or c, whatever I told you to solve for. Some multivariable equations, and now today radical equations. I might have forgot a couple too along the way, but anyways, and I'll tell you, before the year's over, we're going to be learning a lot more, okay? We're going to be going to learn how to solve quite a few more types of equations before the year is over. Actually, cubic equations, quartic equations, exponential equations, logarithmic equations, etc. Okay? Alright, now, let me start off by showing you what a radical equation looks like, because I'm telling you, students, it's so important when you look at this list back here that you can look at an equation and say to yourself, this equation falls into this category, or this one, or this one, or this one, or this one, okay? You should be able to do that. Also, I want to explain to you what makes a radical equation a radical equation. So, you can write this example down if you want to. You don't have to, it's up to you. But a radical equation would be something like this. We'll say the 4th root of 2x minus 6 equals 10. Now compare that to this problem over here. The 4th root of 16 plus 2x equals 13. Now, this is not a radical equation here. In fact, this is a good old linear equation. How do you know that, Mr. Earhart? Well, thanks for asking. Because you look at your variable, and the highest exponent of any of your variables is a 1. That's a linear equation. Now, over here, yes, we have a 1 here with the x. I get that, but here the x is under a radical, and that's what makes it a radical equation. And think back to this here, remember? When the x was inside the absolute values, we call that absolute value equation, okay? On this example here, is the x under the radical? Well, of course not, it's over here. The only thing under the radical is a 16. This is not a radical equation, but this is. So what is a radical equation? It's an equation in which the unknown is inside the radical. Or in other words, the x is part of your what? What do we call that thing under the box there? We call it the radicand. Okay? Alright, so that is what a radical equation looks like. If you stop and think about it, in the video that is part 1 of this lesson, we did a little bit of solving radical equations yesterday. Remember, we had like the geometric mean equals square root of 2x. Well, that was a radical equation, wasn't it? Look, remember the formula we used gm like this, and then we solve for x. We did those in the video, the part 1 video. Well, is there not an x under the radical? Sure there is. This would be a radical equation. So we did some pretty simple ones yesterday, or not yesterday, but the day that we watched that video. We did that already, okay? Here are the steps that you will want to use for solving these types of equations. Like always, I put them up here quickly, and I expect you to pause the video at the end and copy them down, okay? First of all, we're going to isolate the square root that contains a variable. You want to get that radical all by itself. I put a square root. That is really poor teaching. It might be a cubed root or a fourth root. Isolate the root. Very sorry, students. Isolate the root that contains a variable. Step 2, then get rid of or eliminate the root. Eliminate the root, and I will teach you how to do that today. Solve the remaining equation depending on what type it is. I'll explain that when we get to it. And then step 4, check your answer due to extraneous solutions. Let me stop and say this. Extraneous solutions are, what's the first part of the word here? Extra. Extraneous solutions are extra solutions that you get sometimes in radical equations. They're extra solutions that don't work. So that's why it is imperative that you check your answer when you're solving radical equations, because there's going to be times where you will get answers that look, you've solved the problem correctly, but if you check your answer in the end, you'll see it doesn't satisfy the equation. That can happen. You can do all of your work perfectly, and then the answers don't work. That can happen. It will happen in your homework, okay? So check your answers to make sure they're accurate, okay? Alright, well, let's jump into 5 examples. Here we go. Please copy this first example down. Anytime I go too fast, pause the video or rewind the video, and we should be good. Here we go. Okay, step 1, here's a radical equation. It's a cubed root equation. Step 1, isolate the root that contains the variable. Well, here's my root that contains the variable right here. Isolate that, get it all by itself, okay? I've got a -2 here. Now, by the way, if the bar went all the way across, then the x minus 2 would be under the radical, okay? That's not the case. So bring the -2 over and make it a +2. So now I'm left with the cubed root of x equals 2. Pretty simple, isn't it? Is the radical all by itself? Is the root all by itself? Well, of course it is. Here's the entire root right here. It's all by itself. Step 2, eliminate the root, or the radical, whatever word you want to use. Root or radical is fine. Well, I'll use those 2 words interchangeably. Well, look, what kind of root do we have? A cubed root. We have a 3 here. So if I want to get rid of a cubed root, I must raise this entire side to the what power? Third power, whatever this number is here. You raise the entire side to that number. However, we have an equation. Thus, both sides are equal. So you can't do something to one side unless you do it to the other side. Now, when you cube a cubed root, they basically cancel out, leaving you with just the radicand. And then 2 to the third power is 8. Look at that, we're done. There was really no step 3 to do in this problem. There was nothing to solve. As soon as we eliminated the cube root, then we were left with this. Now, always check your answer, students. Always. You might get no solution. In other words, if you were to check this answer and find out that 8 doesn't work, then you would cross it off and you would say, no solution. And that will happen sometimes in your homework, and maybe in your notes. I'm not sure. You have not worked those out yet. So here we go. Let's check this. So where the x is, I'm going to put an 8. So the cube root of 8, here's my x, I put an 8, minus 2 equals 0. By the way, always check it in the original equation. Always check it in the very original equation. Alright, the cube root of 8 is 2, and 2 minus 2 is 0. It checks, so we're good. Alright, let's try a more challenging problem. Alright, here we go. We have a radical equation. It is a square root. There's a 2 here, even though you can't see it. It's a square root equation. So Let's get that all by itself, okay? Bring the 1 over. It's a positive 1. Make it a negative 1. So I'm left with the square root of 3x negative 8 equals 2. Step 1 is done. Step 2, now we're going to eliminate the root. Alright? Now, this is a square root, so there's a 2 there even though you can't see it. So we're going to raise this side to the second power. And we're going to raise this side to the second power. Alright? Now, the reason I raised this side to the second power was to get rid of this radical right here. So when you square a square root, they cancel out, leaving you with just the radicand. Over here on the right side, 2 times 2 is 4. So step 2 is done. I eliminated the root. Step 3, solve the remaining equation depending on what type it is. Well, when I look at this, I can tell right away it's a good old-fashioned, easy linear equation. We know how to solve this. Bring the 8 over, make it a positive 8. So I'm left with 3x equals 12. Divide both sides by 3 and x equals 4. So I did step 3, I solved the equation. Now step 4, check your answer. So let's check our answer. Okay, here we go. I'm claiming the answer is 4. Let's find out. I have 3 times 4 minus 8 under the radical. Okay, so what's 3 times 4? 12. What's 12 minus 8 or 12 negative 8? 4. So this whole entire radicand became 4. Then bring down your positive 1. Bring down 3. The square root of 4 is 2. Plus 1 equals 3. That's true. 3 equals 3. Check. Booyah. We're good. That is the answer. Alright? Okay, guys. I hope I'm not going too fast. I mean, it's pretty simple. Isolate the square root. Isolate the root. Eliminate the radical. Solve the remaining equation. Check your answer. Let's try another one. Getting a little more difficult now, okay? If I can get my pen to work here. Alright, here we go. Now, this is another radical equation because I have an x or a variable under the radical. Now the first thing I need to do is isolate the root. Now here's the root. This 2 is not part of the root. It is not. So I must get this all by itself. So there are 2 numbers I have to get rid of. A 2 and a 15. Now, always save these multiplying numbers. And when I say multiplying numbers, here's what I mean. The 2 is right next to the radical. That means the 2 is multiplying itself times the radical. Always save the multiplying numbers for last. Always. Okay? So let's go ahead and first of all bring the 15 over and make it a negative 15. Alright? Easy enough. And now we're left with 2 square root of 15 negative 7x equals 4. Now the radical is still not isolated. I must get rid of this 2 right here. Alright? So the 2 is multiplying times the square root. So I'm going to divide by 2 and divide by 2. That will cancel these 2's out. Leave me with the square root of 15 minus 7x equals 4 divided by 2 is 2. Now, this is a square root. Well, let me stop and say this. Is step 1 done? Have I isolated the root? I have. It is all by itself on one side. Now I'm going to eliminate the radical or the root. In this case, it's a square root. There's a 2 here. So I'm going to raise this entire side to the second power to get rid of this square root. However, what you do to one side, you must do to the other side. Alright? So here we go. Square a square root. All this cancels out, leaving you with the radicand. And then on the right side, 2 squared is 4. And now, solve the remaining equation depending on what type it is. So let's solve this thing, okay? Pretty simple. Here we go. This is a linear equation to solve for x, so bring the 15 over and make it a negative 15. And we're left with negative 7x equals negative 11. Now divide both sides by negative 7 and you get, well, a negative 11 divided by a negative 7 is positive. I would not put a decimal. You've got to use exact numbers up here when you check it. Please do not use a decimal. You can use 1 and 4/7, although I would recommend leaving it just 11 over 7. There's your answer, 11 over 7. That's what I would do, okay? Now, after you're done checking this answer, we did did step 3. Now we're on to step 4. After you're done checking your answer, if you want to write your answer as a decimal, that's fine. But if you were to try to write this as a decimal, you would get, I'm typing it in now, you would get 1.57142857. I mean, you're going to have to round it, and it's not going to give an exact equal statement at the end. So leave it exact numbers, okay? Now here we go. See this 15 minus 7x? I really have, well I better write this out so we can see, it's a little confusing. 15 negative 7 times 11 over 7. And then bring down your positive 15 equals 19. Now, if you struggle with stuff like this, use your calculator. First of all, you don't subtract first. You don't take 15 minus 7 first, you do your multiplication first. We have negative 7 times 11 over 7. That gives you a negative 11. Negative 7 times positive 11 sevens gives you negative 11. So now I have 15 negative 11. This times this gave me negative 11. Now 15 minus 11 is 4. So now I have 2 square root of 4 positive 15 equals 19. Okay? Everybody see that? 15 minus 11 is 4. Now, right here is 2 times the square root of 4. So 2 times, what is the square root of 4? 2. Please don't put the square root of 2. That's not right. The square root of 4 is just 2, because 2 times 2 equals 4. So the square root of 4 is 2. Then bring down your positive 15. Now 2 times 2 is 4, so we have 4 plus 15, or 4 positive 15. That gives you 19, which equals 19. Alright? Checks. So this is my right answer. So you can put 11 sevenths. You can put 1 and 4 sevenths. Or now that you're done checking it, if you want to put a decimal, I have no problem with that. 1.57 rounded. Any of those would be fine. Alright, the next two, the last two we're actually going to look at are pretty difficult. So here we go. Let's really be ready to think on these. Now this is a radical equation because I have a radical, in this case a square root, with variables inside the radical. So I have a radical equation. Now, remember I use the words root and radical interchangeably, so don't let that confuse you. So step 1 says isolate the root. You could also say isolate the square root, but here's the problem. How can you isolate them? There's 2 of them, okay? So here's what we're going to do. We've got to we're going to isolate one of these. Now, listen to my common sense reasoning. You can bring this entire radical over. It's a positive radical. And when you do, the entire radical becomes negative. Notice nothing inside the radical changes. I don't mind doing that, but look what it leaves me with. It leaves me with a negative sign here. So my radical is still not isolated. Then I have to go through and change signs. That's a mess to me. I don't want to do that. So I'm going to move this radical over instead. So Mr. Earhart, I'm confused. Which radical do I isolate? It doesn't matter. It doesn't matter. You'll get the right answer either way. I'm just saying, I think it'd be easier if we move this radical over. It's a negative radical. So if we move it over, it becomes a positive radical. Do you see what I'm saying? Now here's what's going to get really tough in about 3 seconds, okay? Did not want to do that. Now, let's try to copy this correctly. I did, okay, good. So now, this radical's gone. This is all that I have right here. Square root of x plus 3 equals 1 plus the square root of x minus 1, okay? Now, this is going to get a little tough, so here we go. However, even though it's going to get tough, if you'll listen to me, I will really help you here, okay? Now watch carefully, please. Here we go. We have isolated one of the roots. So now we're going to eliminate this root. Why not this one? Because this is the one I isolated. Whichever one you isolate, get rid of it. So let's eliminate the square root. Are you ready? This is a square root. So we've got to take this entire side and square it. Hold the horses for a second. If we square one side, we've got to square the other side. Alright? Now, if I square a square root, I'm left with the radicand. Everybody see that okay? That's easy. Here's the killer part right here. Now watch, this is where it gets really tough. I'm going to take this and I'm going to work this out on another page, okay? So here we go. See this entire expression right here? Watch this. When you have a two-term expression to the second power, that means you're going to write the parentheses twice. Okay? This is where it gets really tough. I need you to focus, okay? So because I had a 2 here, that means write the parentheses twice. Now I'm going to do a bunch of multiplication. I have two terms here. 1, 2, and I have two terms here. 1, 2. Alright? Now, remember if you were doing something like x plus 5 times x minus 6, you would take this x and multiply it through, then take your positive 5 and multiply it through, right? Exact same thing. Let's take your 1 and let's multiply it through. 1 times 1 is 1. 1 times anything is itself, so 1 times this radical is just the radical. Got it? Now, let's take this radical and multiply through this entire radical right here, okay? So the square root of x minus 1 times 1, well, anything times 1 is just itself. Okay, and then take this times this. Well, guys, this is an old-fashioned shortcut. Hopefully you've learned this somewhere along the way. If I take the square root of 5 times the square root of 5, it just equals 5. Anytime, no, it has to be a square root. It has to be a square root, but anytime you multiply a square root times the exact square root, you get out the radicand, because square root of 5 times square root of 5 is square root of what? 25, which is what? 5. So anytime you match, you might want to pause the video and write that down, okay? Anytime that you multiply matching square roots, you'll get out the radicand. So if I'm multiplying the square root of x minus 1 times the square root of x minus 1, well, they're identical. I'm just going to get x minus 1. There we go. That's it. So this entire expression right here, now we're going to do some of these in your homework. I've only given you one in your notes, okay, but we're going to do some in your homework, so you'll get some more practice, okay? But that entire expression, this entire expression right here, now became this right here, alright? So there we go. Now, let's see what happens here. Let's really do some good simplifying, okay? First of all, I have x plus 3 on the left side. Everybody okay with that? Now I have a positive 1 here and a negative 1 here. So if I add those together, they're going to cancel out. I would have a 0. Now you do not need to put the 0, but I'm just showing you they would cancel out. So positive 1 and negative 1 would cancel out. Now I have an x here, so bring down your x. Okay. Now, what did we learn the other day? The square root of 5 plus the square root of 5 is what? If the insides match, you just write the square root of 5. There's a 1 here and a 1 here. So the square root of 5 plus the square root of 5 would be what? 2 square root of 5. Do you see it? We learned that the other day. So apply that to this. We have square root of x plus minus 1, square root of x minus 1. Well, there's a 1 right here on the outside, 1 on the outside. Do the indexes match? Yes, they do. Do the radicands match? Yes, they do. So you would write the square root of x minus 1 and then add your outside numbers, positive 1, positive 1. That's positive 2. Students, look what we did. We've gotten this entire equation down to how many radicals. Up here at the beginning, we had how many radicals to deal with? 2, didn't we? Now we only have 1. So let's eliminate this radical now. How do you eliminate this radical? Well, you're going to have to, unfortunately, get the radical all by itself. So we've got to get rid of the x, and we've got to get rid of this 2. So the radical's all by itself. Do you see? Do you see why I'm doing that? I'm really not done with step 1 yet. I'm not done with step 2. I have not eliminated the square root, or the root. There's still 1 left. So let's go back to step 1. Let's isolate this. So bring the x over and make it a negative x. When I do that, what happens to the x's? They cancel out. So now I'm left with 3 equals 2 square root of x minus 1. Now, divide both sides by 2, okay? To get rid of the 2. Divide both sides by 2, and now I'm left with 3 halves equals square root of x minus 1. There, I did it. I isolated the square root. Now let's eliminate it. This is a square root. So to get rid of a square root, we got to raise this side to the second power. If I raise one side to the second power, I must raise the other side to the second power. Well, I'm squaring the 3 and I'm squaring the 2. I'm squaring 3 halves, so 3 times 3 is 9. 2 times 2 is 4. And over here, when you square the square root, it canceled out, leaving you with x minus 1. So look how close we are to solving this. Man, all I have to do is bring the 1 over and make it a positive 1. So bring the 1 over and make it a positive 1. The 1's gone. We're left with x. And you'll get 3 1/4. Now, here is where you've got to let your calculator do the work for you if you struggle with this. Type into your calculator 9/4 plus 1, enter math, enter, enter. I would not make any of these decimals because you have to check your answer. Now, the calculator probably said 13 over 4. I have no problem. In fact, that's actually what I'm going to use is 13 over 4. Also, I can use either one of these two answers, okay, as long as they're not decimals. So, either way, there's your two answers. Now, let's check our answers, okay? I'm going to use 13 over 4. Let's check our answer. You ready? With the calculator, if you put 13 over 4 right here with x, go ahead and take 13 over 4 plus 3, okay? And you're going to get 6 1/4. You're going to get 25 over 4. Okay? So 25 over 4, then bring down your minus sign. Now, right here for this x, go ahead and put 13 over 4. So with your calculator, type in 13/4 minus 1, and you're going to get 9 over 4. 9 over 4. Alright, let's continue. The square root of 25 over 4, well, that's the square root of 25 and the square root of 4. The square root of 25 fourths would be, well, the square root of 25 is 5. The square root of 4 is 2, so 5 halves. The square root of 9/4, well, the square root of 9 is 3, and the square root of 4 is 2. And now if you take 5 halves minus 3 halves, you will get 2 halves, which is the same thing as 1. So it does check. Alright? It does check. Alright, let's continue on. Last problem. Last one. Here we go. Now, this one looks a little tricky, okay? However, excuse me. Remember, we can rewrite these rational expressions as radical expressions, okay? Now I'm going to solve this problem two different ways, and I expect you to take notes both ways, and then you can choose which method you like the best, okay? Here we go. First of all, is this a radical equation? Well, yeah, let's write it like one, okay? The 2/3 goes to the x plus 4, so I'm going to put 2 from this 2 right here, then a radical, then x plus 4. All of that goes under the radical because it's in parentheses. Here's the bottom of my fraction, it goes right here. Here's the top of my fraction. Now the top of the fraction does not go here with the 4. It goes with the entire x plus 4. So it's x plus 4 to the second power. Alright? Equals 8. Got it? Stop and look and make sure you can see what I did. I wrote it from rational exponential form to radical form. Everybody see that? The 2 is not inside the parentheses, so it goes outside the radical. Here's my radical box. The bottom of the fraction is your index. The top of your fraction is your power to the entire base. And your base is x plus 4. Okay, now, let's do this. We have a radical equation, right? Here we go. Step 1, isolate the square. Isolate the root. Alright? Well, there's a 2 I've got to get rid of. It's multiplying, so I divide both sides by 2. And I'm left with the cubed root of x plus 4 quantity squared equals 4. 8 divided by 2. Now, is the radical isolated? Yes, it is. Next, eliminate the radical. Alright, here we go. I have a power, an index of 3. So I'm going to raise this power, raise this side to the third power. If I raise one side to the third power, I must raise the other side to the third power. So when you cube a cubed root, all of this cancels out, and you're left with the radicand. Like this. Over here I would have 64, because 4 times 4 is 16 times 4 is 64. Now, we learned this when we were doing completing the square. Remember how we have a parenthesis to the second power? if I want to get rid of this 2 right here, I can just simply take, it's a 2, right? So I can take the square root of this to get rid of this 2. But if I take the square root of one side, I better take the square root of the other side. So the square root cancels with the 2, and I'm left with x plus 4. The square root of 64 would be plus minus 8. Now bring your 4 over and make it a negative 4. So there's what x equals. It actually equals 2 numbers. X equals positive 8, negative 4, and x equals negative 8, negative 4. So if you simplify this, you will get 4. And if you simplify this, you'll get negative 12. Alright? So let's check these answers in the original problem here, okay? So I'm going to put a 4 right here. 2, and then 4 plus 4 is 8. So 8 to the 2/3 power equals 8. So with your calculator, you can type in 8 to the 2/3 power. Okay, nothing wrong with doing that. That'll save us a little bit of time. Make sure you put the 2/3 in parentheses. 8, arrow, parentheses, 2/3. 8 to the 2/3 power, and you'll get 4. So now I have 2 times 4, because this whole thing right here equals 4, and 2 times 4 is 8. Excellent, this answer checks. Now let's check negative 12, okay? So negative 12, here we go. I'm going to put a negative 12 right here for x. Negative 12. So I have 2 parentheses negative 8 to the 2/3 power. Now students, it is imperative that when you type this into your calculator right here, you put like this parentheses around the negative 8, then hit your exponential button, your arrow, then parentheses again, 2/3. It is very important that you do that, okay? Always, if there's parentheses around it, you type it in with those parentheses. That's a very good habit to get into, alright? And you will get 4. So I have 2 times 4 equals 8. 8 equals 8. Check, check. So there's my 2 answers, 4 and negative 12, okay? So let's review before I show you another way to do this. And please don't tune me out and get mad at me, okay? Listen, there's another way to do this. You might like the other way better. But let's quickly review. When I saw this rational exponential expression, I rewrote it with a radical like this. And then once I rewrote it with a radical like this, I knew what to do. But there might be a faster way you would like better. Another way to do this is to isolate the rational exponent and its base. So isolate that, okay? Watch, this is a really cool method. You might like this better than writing it with a radical, okay? So I'm going to divide both sides by 2 to get this parentheses all by itself. Cancels, leaves me with x plus 4 equals 4. 2/3 power. Now, what power do you want to get rid of? You want to get rid of the 2/3, right? Sure you do. So, I want to need a little more room here. That's why I keep trying to move this around. I need a little more room to write something in here. There we go. We want to get rid of this 2/3. So here's what you can do. It's so fast and it's so cool. You can raise this entire side to the 3/2 power. Why would I use 3/2? It's the reciprocal of this. And I'll show you why in a second. So if I raise this entire side to the 3/2 power, I can come over here and raise this side to the what power? 3/2. Same thing. Now, when you raise a power to a power, you multiply the exponents. 2/3 times 3/2 is 1. So now I have x plus 4 to the what power? 1. Well, guys, anything to the 1 power is just itself. If I have 512 to the 1 power, that's just 512. So x plus 4 to the 1 power is just what? X plus 4. And now 4 to the 3/2. We'll type that in your calculator real quick. Type in a 4, and then an arrow, and then 3/2. And you're going to see you're going to get 8. So 4 to the 3/2 is 8. Alright, now bring the 4 over and make it a negative 4, and you get 4. Now, notice we did not get one of the answers. Okay? And that's one of the negatives to using this method. And all that I can say is when you do this, when you're checking, when you're using a method where you raise it to a certain power like this, just make sure that you check for extra solutions by doing this. When you took this side of the 3/2 power, you must realize your denominator is a 2, right? Which is the same thing as a square root. Think about it. If I told you to write this with a radical, it'd be the square root of 4 to the 3rd power. So if you're inserting a 3 to the 3, if you're inserting a 3/2 power, that's the same thing as inserting a square root. So you do need to put plus minus. That's the only drawback to this method. You gotta watch for stuff like that. So if you're pretty sharp with catching stuff like this, is a faster method. If you're not, then just use the radical method like I taught you, and you'll be fine. Okay? Now relax. We've got plenty of homework to practice. You'll get plenty of practice, so don't worry about that, okay? Alright, that's it for today. I hope this video's been a help to you. If you have any questions, don't hesitate to call or email.